All right, so welcome back, everybody, for another deep dive. And this time we're tackling something that's pretty fundamental. It's one of those concepts philosophers love to wrestle with. We're going to be looking at truth,
What?
but not just, truth in some kind of airy-fairy way. We're going to be looking at how you can define truth rigorously, like how a mathematician would.
Right.
So to guide us on this philosophical adventure, we've got Alfred Tarski's 1933 paper, which is really considered a landmark in this area.
It really is.
So get ready to have your brains bent a little bit, because this is some pretty intense stuff.
Yeah, the really fascinating thing about Tarski's approach to this whole question of truth is that he wasn't just coming at it from the perspective of, trying to win a philosophical debate. He was really trying to come up with a definition of truth that was as precise and as airtight as a mathematical proof.
Oh, okay. So not just truth in kind of this abstract sense, but truth as it applies to specific sentences within a certain system, like a logical system.
Yeah, exactly.
Right.
Like if you're playing a game, how do you know if a move is legal? How do you know if a move is a winning move?
Right.
It's all about defining what's true within that system.
Okay.
And so what Tarski did was he laid out this whole program, this whole set of criteria for what would count as a really good, rigorous definition of true sentence.
Uh-huh.
And one of the first things that he does is he makes this distinction between what he calls the object language and the meta language.
Okay, hold on. Two languages.
Two languages.
Now we're getting to the really heady philosophical stuff.
Well, it's actually not as complicated as it sounds.
Okay, good.
The way to think about it is this. The object language is the system we're actually investigating. It's the set of sentences that we want to be able to say, okay, is this sentence true or false?
Right. Well,
So it could be something like basic arithmetic.
okay.
And then the meta language is the language that we use to talk about the object language.
Ah, I see.
It's the language that we use to analyze it, to define its truth.
Okay, so it's like we need a language to talk about the language that we're actually analyzing.
Oh, exactly. You can even imagine trying to explain English grammar, but only using English words.
Right.
It would be really difficult. You need a language that can step outside of the system in order to explain the system.
Right. And you're saying for Tarski, that's what the meta language does.
That's what the meta language does. And he even envisioned using something like set theory as the meta language.
Oh, wow. Okay. I'm starting to see how powerful this is. But why all the formality? I mean, could we just define truth in regular language, the language we use every day?
Mm-hmm. Well, that's where Tarski's kind of obsession with rigor comes in. He knew that everyday language is full of vagueness and ambiguity, and he wanted to avoid all of the philosophical muddles that arise when we use a word like truth kind of loosely.
Mm-hmm.
And so by creating this formal system with these separate languages, he could sidestep a lot of those traps.
Okay. So no more hand-wavy philosophical stuff. Everything's got to be, defined with mathematical precision.
Exactly. And that's where his requirement of what he called formal correctness comes in.
Right.
So the definition itself has to be like a well-formed formula in the meta language, and it can't be circular. It can't define truth in terms of itself.
Right.
It's like defining, an even number as a number that's divisible by 2.
Right.
It's there's no funny business going on there. It's just very clear and unambiguous.
I get the clarity part, but but even with all this rigor, doesn't it still feel like we're kind of defining truth in terms of itself? I mean, like to even begin defining it, you kind of have to know what truth is.
Right. You've just hit on one of the big philosophical head scratchers in this whole area. It's called the paradox of material adequacy.
Okay.
And Tarski actually found, I think, a really mind-blowing way around this. He essentially used infinitely many sentences in the meta language to capture the truths of the object language.
Okay. Hold on. Infinitely many sentences.
Infinitely many sentences. It's a bit like this. For every sentence in the object language, you have a corresponding sentence in the meta language that asserts its truth.
Okay.
So, if the object language says 1 + 1 = 2, the meta language would say the sentence 1 + 1 = 2 is true.
Right.
And Tarski's challenge was to find a single formula in the meta language that could generate all of these truth-asserting sentences without running into that circularity problem.
Okay, so it's kind of like a master key that unlocks the truth of every sentence in the object language. But this convention T, as he called it, I mean, doesn't that run into trouble when we we start dealing with things like the liar paradox.
Absolutely. You're right on the money there. Convention 2 works beautifully when you have kind of a well-behaved object language.
Uh-huh.
But if your object language can refer to its own semantics, like it can in the liar paradox, things start to get messy.
Right.
And so what Tarski realized is that in order to define truth for a given language, your meta-language needs to be even more powerful.
So to define truth in something like set theory, which a lot of people think is the foundation of all mathematics,
Yeah.
we would need an even more powerful meta language to even talk about that.
Pretty much, yeah.
Wow. That's both fascinating and terrifying.
Yeah.
No wonder mathematicians sometimes resort to just, good old-fashioned English when they're talking about truth and set theory.
Yeah.
But hey, but I mean, even though there are these limitations, I mean, it doesn't mean that Tarski's work isn't revolutionary, right? I mean, it really does give us this profound new way to think about what it means to define truth and all the philosophical pitfalls that are involved. Now, I'm itching to know what are the specific types of truth definitions that Tarski came up with.
That's where things get even more interesting.
Hmm.
So let's start with what are called the standard truth definitions. Now, instead of going straight for this idea of a true sentence, Tarski actually took a slightly different route. He focused on defining satisfaction first.
Okay, satisfaction.
Satisfaction.
So how is that different from saying that a sentence is just simply true?
Well, it's a subtle but really powerful distinction. So remember that formulas can have these placeholders in them, variables, right?
Right, right.
And those need to get, filled in with specific values before they actually become sentences that we can judge as true or
Yep.
false.
Ah.
So think about, the equation x plus 2 equals 5.
Right,
That's not in itself true or false.
right,
It depends what x is.
right.
And that's where assignments come in.
Okay.
Assignments are what give those variables concrete values, turning the formula into a sentence that we can then evaluate.
Right, right. Okay. So instead of attacking this notion of truth kind of head on, he broke it down into this intermediate step of satisfaction.
Exactly.
Clever. But I still need a concrete example to wrap my head around this.
Sure. So let's take the very simple formula. X is greater than y.
Okay.
And imagine that our assignment says that x is 3 and y is 1.
Okay.
So we plug those in, we get 3 is greater than 1, which is, of course, clearly a true sentence.
Right.
So we say that specific assignment satisfies the formula x is greater than y.
Okay. Okay. I think I'm getting it. But how do we make the leap from satisfaction to a definition of truth for sentences in general?
Well, the really cool thing about satisfaction is that it's compositional. It's kind of like building with Legos. So, if you know how the individual bricks connect to each other,
Right.
you know how to make all sorts of complex structures.
Right.
Similarly, with formulas, if you know which assignments satisfy the individual parts of the formula, you can figure out which assignments satisfy the whole formula.
Okay, so the truth of the whole thing kind of depends on the truth of its parts.
Exactly.
It's almost like how the meaning of a sentence is built from the meanings of the individual words.
Exactly.
Yeah.
And this idea of compositionality is really crucial because it ensures that our definition of truth is actually building up meaning in this systematic way.
Mm-hmm.
It's not just kind of random. We're breaking down complex sentences into these bite-sized pieces, and we're seeing how their truth values contribute to the overall truth value. And that's why Tarski focused on satisfaction, because it's the foundation for building a recursive definition of truth.
Recursive, meaning we start with those simpler formulas and work our way up to those more complex ones.
Precisely. And
Right.
for those basic atomic formulas, he used these clever counterparts of the object language's predicates, but in meta language.
Okay.
It gets a little technical, but the basic idea is that it allows us to talk about the truth of those simple relations without relying on the very notion of truth we're trying to define.
Okay. So it's all starting to feel very elegant, like a well-oiled machine.
Mhm.
But I remember you also mentioned that Tarski explored this completely different way of defining truth using something called quantifier elimination.
Right.
It almost sounded like a magic trick.
Yeah, it kind of does, doesn't it? And even Tarski himself acknowledged that this method relies on some very specific features of the object language.
Okay.
It's not as generally applicable as his standard truth definitions, but it's still a fascinating way of approaching the problem.
All right. Well, color me intrigued. How does this quantifier elimination thing, how does it work? It's magic.
So imagine that you have an object language where the quantifiers, the for all and their exist statements,
Right.
range over a particular class of objects. Let's call it A.
Okay.
And A could be anything. It could be all the numbers. It could be all the sets. It could be all the cats in your neighborhood.
Right.
The important thing is that the same sentence can have different truth values depending on what A is.
So truth becomes relative to the context.
Exactly.
Yeah.
And so that's why for this method, Tarski used the term correctness in the domain A
Right.
rather than just truth. He reserved truth for the special case where A includes absolutely everything.
Gotcha.
Now, here's where the magic happens. This method, it involves cleverly rewriting formulas to get rid of those existential quantifiers. There exists ones. And what you end up with are simpler statements that just talk about the size of the class A. It's kind of like, you have a really complicated equation and you simplify it and simplify it until the answer just pops out at you.
Okay, so if we know how many things are in A, we can just crunch these simpler statements and then figure out whether the original sentence was correct in that context.
Exactly.
That's pretty neat. It does seem very specific, though. I can see why Tarski called it a lucky accident.
It is. It's a very unique approach, and it shows how Tarski was always, thinking outside the box when it came to defining truth. But it wasn't his final word on the matter. He actually developed an even more powerful and more general definition in 1956, building on this growing field of model theory.
Ah, yes, the model theoretic definition. I remember you mentioned that model theory brought this whole new level of flexibility to logic,
Right.
where symbols could have different interpretations in different contexts.
Right.
It's not like a playground for philosophers.
It is. By the 1950s, logicians were really starting to explore how language could be used, not just to describe some kind of fixed reality, but to model a whole range of possible worlds, each with its own rules and interpretations. Think about how the plus sign means something different when you're adding numbers versus when you're adding vectors.
So meaning became more context dependent. Like the same word could have these different shades of meaning depending on who's saying it and in what situation.
Exactly.
Yeah.
And so this new kind of flexibility, it posed a challenge for Tarski's earlier truth definitions. How could he adapt them to this more fluid world where symbols could kind of dance between all these different interpretations?
Sounds like he had a new puzzle to solve.
He did.
Did he manage to bridge the gap between his earlier work and this new model theoretic way of thinking?
He did brilliantly, and he did brilliantly. The 1956 definition, which he developed with his colleague Robert Vaught, it directly defines truth. Relative to a specific structure. So it's a really powerful generalization of his earlier ideas, and it fits perfectly into this world of context-dependent meanings.
So instead of saying a sentence is just true, we say it's true in this particular structure. It's all about specifying the context.
Exactly. It's a subtle shift, but it has some really profound implications because now the symbols in model theoretic language become like those words in natural language whose meaning depends entirely on who's speaking and where they are, like I or here.
Right.
Philosophers call these indexicals.
This is really stretching my brain in all the right ways. We've gone from this incredibly formal, almost rigid notion of truth to this much more nuanced, context-sensitive understanding. But I have a feeling this story doesn't end there, does it? Didn't even Tarski's incredibly powerful definitions encounter some roadblocks along the way?
You're absolutely right. Even Tarski, with all his brilliance, couldn't anticipate every twist and turn in this quest to define truth. And in 1961, a logician named Leon Henkin pointed out some really fascinating cases where those standard definitions didn't quite fit.
Oh, okay. So even the mighty Tarski had his limits. Okay, I'm all ears. What kind of logical beasts managed to stump him?
Well, Henkin focused on what we might call non-standard languages. These are systems that really push the boundaries of what we traditionally consider in formal logic. One example involves languages with infinitely long chains of quantifiers. So imagine a sentence that starts with, for every X, there's a Y, such that for every Z, there's a W, and it just keeps going forever.
Whoa, my brain just did a loop-the-loop. It's like those Russian nesting dolls, but with quantifiers instead of wooden figures. Infinite regression. Did Henkin just want to give logicians a migraine?
It might seem that way, but these infinitely long formulas, they really threw a wrench into Tarski's recursive approach. Because remember, his definitions built up truth from simpler formulas to more complex ones.
Right.
But with these endless chains, there's no clear starting point for the recursion. It's like, trying to build a tower that's infinitely high.
Right.
Where do you even begin?
So how do you escape that infinite abyss? Did logicians just throw up their hands and say truth is a mystery?
Not quite. They found a really clever workaround. Instead of defining truth recursively, we can go straight to defining a satisfaction relation, much like Tarski did in his 1933 paper. The key is to make sure that the conditions we place on this relation are strong enough to nail down a unique one, even without that step-by-step recursive process.
Okay, so we kind of bypass the construction process and go straight to the finished product.
Yeah, exactly.
I like the way these logicians think. But Henkin wasn't done yet, was he? What other linguistic curveballs did he throw into the mix?
His second challenge involved languages where the quantifiers aren't neatly ordered.
Hmm.
So in standard logic, one quantifier clearly comes before the other. Like for every x, there exists a y.
Right.
But Henkin explored languages where this order is relaxed, allowing for much more complex relationships between those quantifiers.
Okay, I'm going to need an example here. How do these out of order quantifiers actually work in practice?
So imagine that we're talking about gifts. A standard sentence might be, for every person X, there's a gift Y, such that for every occasion Z, if X likes Z, then X would be happy to receive Y on Z.
Okay,
Great.
yeah.
Now tweak it slightly.
Yeah.
For every person X, there's a gift Y, such that for every occasion Z, regardless of what else they might want, if X likes Z, then X would be happy to receive Y on Z.
Ah, I see. It's like saying that there's this universally perfect gift for each person, no matter what.
Exactly.
The order of those quantifiers really does make a difference. But how did this mess with Tarski's definitions?
Well, these nonlinear quantifiers, they demanded a more sophisticated notion of satisfaction. Instead of just asking which, single assignments satisfy a formula, we need to consider sets of assignments and whether they satisfy the formula uniformly, meaning the satisfaction holds regardless of the values assigned to certain variables.
So we've gone from individual assignments to whole sets of them.
Exactly.
This is getting pretty deep into the logical weeds.
It is, but it's a testament to the incredible complexity of language. Even seemingly simple things like quantifiers can have these hidden depths that challenge our attempts to capture meaning formally.
So these non-standard languages, are they just, a logician's playground, or do they actually reflect something about how we use language in the real world?
They're much more than just abstract puzzles. They really offer a glimpse into the intricate ways that we use quantifiers in everyday speech. The way that we talk about, everyone and someone is often more nuanced and more flexible than what standard logic can capture. And these non-standard systems help us appreciate that full expressive power of human language.
Wow, we've covered a lot of ground in this deep dive, from Tarski's grand vision of defining truth to these specific types of truth definitions, and then even to those cases where his framework gets a bit stretched. It's like we've taken a whirlwind tour through this vast landscape of truth and logic.
It has been a fascinating journey, and Tarski's work was truly revolutionary. It not only changed how we understand truth in formal languages, but it continues to shape how we think about meaning and logic and even the very foundations of mathematics.
It's been a mind-bending adventure, that's for sure. And the best part is it leaves us with more questions than answers. If truth is so deeply connected to context, to the specific structures we're working within, what does that mean for our everyday understanding of truth in a world that's full of such diverse perspectives? It's a question worth pondering, and I encourage everyone listening to keep exploring it, keep those philosophical gears turning. Until next time, keep seeking truth in all its messy, magnificent complexity.